Okay, good morning. Today we're going to discuss the rate of chemical reactions. All right, and basically that means how fast or how slow a chemical reaction occurs. All right, and how fast or how slow a chemical reaction occurs is affected by several different factors. Today we're going to discuss 4 of them. Okay, today we're going to discuss how temperature affects the rate of a chemical reaction, how hot or how cold the environment is that the chemical reaction is occurring in. Okay, we'll talk about the concentration of the reactants, meaning how much of the stuff of the reaction is there, how many atoms are actually there that are going to be able to react with one another. The surface area, meaning how many of those atoms are exposed. Is it in a block and there's atoms all packed inside that block, or is it in a fine powdery dust where you have all these molecules spread out throughout for them to react with the other chemicals in the reaction? Okay? And is there a presence of catalysts? Okay? Many times these catalysts are basically like little biological, or they could be biological or chemical substances that control a reaction. Like they're in charge and they take molecules and they cause them to combine or they cause them to break apart. And they don't break down during the reaction, but they're there to say, hey, you molecule over there, you need to join with this molecule over here, and they form a bigger molecule in a reaction. Okay? So let's first talk about temperature. Okay? And how temperature affects the rate of a chemical reaction. Well, if you increase the temperature, what does that do to molecules? Well, if you remember from when we talked about the phase changes, you remember that as temperature increases and as energy is absorbed by a substance, the molecules of those substances start to move faster. Okay? So the increased temperature, or let's just do this. We'll do a single line, an arrow. The increase in the temperature leads to an increase in the speed of the molecules in the reaction. Okay? Now think about that for a second. If those molecules are moving much faster, they're going to collide with each other much more. Okay? So that leads to more collisions. Of the molecules that are reacting. Okay? And that therefore leads to more reaction. All right, a faster reaction. Okay, so the increased temperature, increased speed of the molecules in the reaction, more collisions of the molecules in the reaction leads to a faster reaction. Okay? And the opposite is true. Okay, so if you have a decreased temperature of the environment, and now realize we're talking about the environment that these molecules are in, that's going to lead to a decreased speed of the molecules, a decrease in the speed of the molecules, okay? Repeat that. And that's going to lead to less collisions. Okay? And all of those things added together result in a slower reaction. Okay? So they revealed that. So basically, if you heat something up, the molecules in the reaction will occur faster. If you cool something down, the reaction will occur slower. Now think about that. That occurs with cooking. When you cook something, like you make a cake, you mix all these ingredients together. You start heating it up and heating it up and heating it up so that the molecules will react with one another. All right. A student brought up the other day, what about glow sticks? Well, why do we put glow sticks in the fridge? Well, they'll last longer because what's actually occurring in one of those glow sticks is you have two chemicals inside that stick, and when you break the stick, the chemicals mix and start reacting, and it causes a light to be given off. Okay. In order to make them last longer, you put them in the fridge or the freezer or wherever you want to put them. I would suggest the fridge, so you don't want anything to expand in the freezer if there's any water in it. But if you put it in a colder area, all right, it'll slow down the reaction, so the light will last longer for you. Okay. The next thing we're going to discuss is the concentration. How many reactants? How many molecules are present? Okay, so we're talking about concentration. Oops. Okay. Now, the more molecules that are present, the more the molecules are going to collide once again. So the more collisions there are, the faster the reaction there will be. Okay, so with concentration, it's similar in essence to when we talk about temperature, in the fact that the more collisions there are, the faster the reaction will occur, and that's gonna be true for all the factors that affect a reaction. The more collisions there are, the faster the reaction will be. Okay, so the higher the concentration, the increased concentration, that means more molecules are present in a particular space, a particular volume. Okay, so the increased concentration leads to increased collisions. Okay. Leads to results in a faster reaction. Okay? And therefore, the opposite is true. So a decreased concentration which is there are less molecules in a particular volume or space, leads to decreased collisions and a slower reaction. Okay? Okay. Next, we're going to talk about surface area. And how surface area affects the rate of reaction. The greater the surface area, the greater the rate of reaction. Now, what the heck does that mean? Well, think about it like this. That's the surface area is the amount of molecules that are exposed to the reaction. And you can think of it like a log burning on a fire. When you burn a log on the fire, only the outside of the log burns. All right? If you grinded that log up into sawdust and threw all the sawdust on the fire at once, it would burn really, really quickly, as opposed to a log burning really, really slowly, because the surface area is the exposed molecules. Another example would be candy. If you have a Jolly Rancher and you're sucking on a Jolly Rancher, the enzymes and the chemicals in your saliva only break down the outside surface of that Jolly Rancher. So if you chew it up, you expose all the inside molecules to the enzymes and the chemicals in your saliva to break that down. And therefore, the chewed up Jolly Rancher will dissolve much faster. So when you chew something up or you grind up a log, all right, the smaller pieces, if it's the same amount of mass, grind it up into smaller pieces, has more surface area. Okay, so, and therefore, the reaction will occur more quickly. Okay, so the increased surface area and that means more exposed molecules leads to a faster reaction. And you can remember that as chewed candy versus unchewed candy, or sawdust versus a big log. Okay, so therefore, a log or a big chunk of candy has a smaller surface area. So smaller surface area leads to a slower reaction. Because there are less exposed molecules. Okay? And you can think of that as the big log or the big chunk of candy, right? The full Jolly Rancher. So if you want to enjoy the Jolly Rancher longer, don't chew it because it'll break down much more quickly if you're going to chew it up. Okay? And you've probably all realized that, especially if you've ever had lollipops or other types of candy. Okay? All right, now the last factor that we're going to discuss that affects the rate of chemical reactions is the presence of a catalyst. Okay? And a catalyst is just a chemical that helps speed up reactions. Okay? It'll increase the rate of the reaction, but it isn't broken down. Okay? So catalysts don't get broken down in the reaction. They help that reaction move along. Okay, so the more catalysts that are present, generally speaking, the faster the reaction. Your body is full of catalysts, and we call those catalysts in your body called enzymes. Okay, sometimes those enzymes, what they'll do is they'll say, hey, you molecule over here, you're going to join with this molecule over here. They cause them, they basically help the reaction along, and a new molecule is formed. So the more of them that are present, the faster the reaction will occur. Okay, so catalysts. The more catalysts such as enzymes that are present leads to a faster rate of the reaction. Okay? And like I said, you can think of that like the enzymes in your body, right? And they're basically chemicals, and they have specific shapes. And what they do is they say, hey, you molecule over here, you're going to join with this molecule over there, and then they cause them to join together, and you end up with a reaction. And so the more catalysts that are present, the more molecules that are there that can say, hey, you two join together, you two join together. Okay? So that's today's lesson. And if you have any questions, please write them down. Bring them into class. We're going to be discussing this, and you're going to be working on your notebooks in class and the activities and labs that we'll be doing in class. If you have any questions, please write them down and come ask us. Okay?